All right, so let's talk about polynomials. We've encountered, if you look at page 192 in your book, we have seen a whole lot of polynomials. Okay, we've seen a whole lot of polynomials. You look at them all, A through I, you've seen all those. All right, every single, for most of the polynomials that we encounter, we can break them down to a common algebraic expression. And they will take this form, where A represents a real number, and n is a whole number, the variable is a whole number, and the x is my variable. So for example, examples of this one would be, say, 4x squared, or -7. Just a single number by itself can also count. Or -x to the third, or 2x to the fourth. They all follow into that pattern. All right, what we need to know in this is the A has to be a real number. The A has to be a real number. And the positive integer, the exponent here, this exponent has to be a positive integer or the number 0. So positive number or 0 has to be those things. All right, so how does this one fit into that recipe that I just told you? Any guesses how this one fits into this pattern here?
It's a real number.
But how does it fit into that pattern?
It's A.
It is A. And it's a real number. Here's my variable. And I said my exponent could be 0, right? -7x to the 0 power is -7. Because x would be 1. And -7 times 1 is -7. Right? So that's why a whole number by itself fits that pattern. All right? All right, so let's move on. By the way, all these things, this one, this one, this one, this one, they're all also monomials. It's a one-term polynomial. Other ways you can think of it as a monomial. All right, a polynomial, though, has multiple. So here's a multiple term polynomial. We'll start with one called a binomial, which is 4 plus x, 2 terms. The A is 1, right? And the exponent is 1. Remember, it follows this pattern. The 4, x to 0, this one, A is 1, because that's why it's not written, and so is my exponent, that's why it's not written. So that follows it. Here's another one, p to the 15th minus 4p. That's also a binomial or polynomial. Or -y to the 10th plus 3y. It all fits the pattern. Polynomials can be certainly bigger than those. X squared plus 2x plus 4. Trinomial. Okay, but generally we can call them all polynomials. This just happens to have 3. They can have 4. They can get bigger than that. All right, so they fit all kinds of things. All right, so far so good. All right, so true or false? this is a polynomial. True or false? Does it fit the rules?
No.
It's right, it's false. Does not fit the rules because my exponent is a negative number. Exponent has to be positive. Okay? Is this one a
No.
polynomial? And the answer is no, it's not. It's false because it does not have the correct form of that.
There can't be the bottom part.
Right, there would not, you couldn't have the bottom part. Otherwise, it'd be a binomial, but that bottom part doesn't fit the definition. What about this one?
No.
Negative exponent. It could be a negative coefficient, but not the negative exponent. Okay, so the rules are the coefficient has to be a real number. So your coefficient has to be a real number. This must be a real number. And the exponent of the variables must be whole numbers. A whole number starts with 0 and goes up till whatever. So they have to be whole numbers. All right. So far, so good? Okay, next fact-based thing. Degree. Not talking about deodorant. Not talking about temperature. Degree. Polynomials have degrees. Polynomials are the sum of the exponents of the variables in the term. So here's a third degree polynomial. It's like a third degree black belt. Third degree polynomial. What is my exponent? It's a 3. What about this one? That's third degree also, because if I add them all up, I have 3 degrees there. Here's another one. It's the sum of the exponents of the variables in the term. 2 plus 1, third degree. Okay? Here's a 5th degree. Here's a 5th degree. 4x squared m to the third. The sum of my variables equals 5. All right. Now, when I get to, say, a trinomial or binomial or any kind of nomial, I look for the one that's the biggest. What degree polynomial is this one?
Y, Z.
It's a third degree because of x, y, z. Good. What about this one? This one's a third. 4. It's a 5. What degree is this one?
5th degree.
5th degree. All right. All right. Now, 4x to the 5th is the biggest one. Take each of these individually. That's the biggest one, yes. What's the biggest one in these three of this polynomial? Right. So that's why it's a third degree. Now, it is traditional when you write down polynomials to write them down in descending order of degree. Biggest degree first, smallest degree last. All right, so in this case, this one would be right. In this case, we want to flip-flop these two. Okay, it's traditional to do that. Okay, whichever one has the biggest degree goes first. And you work your way down. All right, what that all means for us mathematically is this. How do we add our polynomials? Finally, the last bit of information. All right, how do we add those up? We add up all like terms. So look at our x to the thirds.
There's 2 of them, so you have 2x to the third.
2x to the third plus 1x to the third.
3x to
So 3x to the third. Now you add up your x squares.
You don't have.
I don't have any more but the 1.
3x squared.
So plus 3x squared. Now add up my
Plus 6.
my whole numbers. So plus 6. Done. Aren't those easy? Okay, let's try one more. These are super easy. Because all you have to do is add like terms. If they're not alike, you can't add them. Okay, how many x to the thirds do I have?
1.
I only have one of them, right? So 3x to the third. That's the first one by degree. Now I'll add my x squared,
You have 2 of them.
and I'm subtracting them. Minus.
So would it just be plus 2?
What is 2 minus 1?
1.
1.
Wait,
So
why is
x
it only
squared.
minus 1?
Minus x squared. Plus
Minus x
squared.
plus x squared. Because 2 minus 1.
Why is
Right.
that only 1 though?
What else would this one be?
Well, wouldn't you make it negative?
Negative 1. 2 minus 1.
What?
2 minus 1. What is 2 minus 1?
1.
1. So what's
What? That's so confused.
Wait, what?
But don't you move the negative sign to the x? So
Okay,
isn't
so
it
that would be
negative x to the
plus negative
second?
plus plus.
Yeah.
Okay, so it's still 2 minus 1.
How do you get 2 minus 1?
2 minus 1.
Oh! I thought we were doing the
No, we're
exponents.
putting-
Oh my gosh, I'm so confused.
We're not doing the exponents at all. Nothing changes but the coefficients. All right, minus x plus 7x.
6x.
Okay, plus 6x. 4 plus 5.
9.
Done. All we're adding is the coefficients. The variables will not change on these because we're not multiplying them. If we're multiplying them, which we'll do in the future, those will change. But we're not multiplying, we're adding them, so the only thing that changes is the numbers in the front. Unless we take it down to 0. If we take it down to 0, then they're gone. But we didn't take anything down to 0, so they stay. Okay? Any more questions?